Hello, everyone. Welcome to webinar number 7 in a series of quality-related webinars presented by the MPIA Quality Alliance, a subcommittee of the Montana Photonics Industry Alliance in Bozeman, Montana. Thank you for joining us. My name is Mary Johnson. I'm CEO of Wavelength Electronics. We design and manufacture the electronics behind precision laser diode systems. The subject of this webinar is the process for equipment management, both preventive maintenance and calibration. Our goal is to give you the structure of an equipment management process that you can immediately implement with simple tools after watching this webinar. First, why should I proactively manage and calibrate my equipment? Maintaining equipment takes time and human resources. Why would I want to plan to proactively service and calibrate tools? If you have a frugal manufacturing manager, you need to be able to justify the expense and effort. Then, how best to set it up? My company manufactures electronics. We have everything from sophisticated robots that place parts on circuit boards, oscilloscopes that test electronic performance, and simple soldering irons. Other Quality Alliance members build lasers. They need to align optics in mechanical housings to spec. I'll share our experience so you can extrapolate it to your situation. And third, once a plan is made, how do you make sure the plan is being followed and is effective? And to finish, what can you do right now? Where do you start? So let's start with some definitions. First, preventive maintenance. This is maintenance performed on a regular basis, intended to prevent failures or detect developing failures. A plan should include the maintenance action, the frequency it is repeated, and monitoring to detect changes in performance. An example is changing the oil in your car. The action is draining the oil, putting the plug back in, replacing the oil filter, and refilling the reservoir with the correct grade of oil for operating conditions. The frequency is usually defined in number of miles the car is driven or months, whichever is less. Monitoring is checking the oil level in the reservoir to make sure the engine will stay lubricated during operation. Calibration is comparing measurement values delivered by a device under test with those of a calibration standard of known accuracy. For example, we build laser diode drivers that need to deliver a known amount of current to a laser. If I tell a customer it will deliver 5 amps, I need to measure the output with a calibrated multimeter to make sure it performs as expected. So first, let's address why I want to plan to proactively maintain and calibrate my equipment. The biggest reason is to avoid a production shutdown. If one of my pick and place machines goes down unexpectedly, parts can't be loaded on the circuit boards. My ability to build is crippled. I'm no longer invoicing. Think of the car oil change. If you let it go too long, you may end up in the middle of nowhere on the side of the road with an engine failure. Your road trip is over. Equally important is that if I'm reacting to a failure, I'm in panic mode. I don't have time to think of permanent solutions. I can only band-aid the problem and contain its effect. If I monitor the equipment regularly, I'll know if a belt is starting to fray or if a motor is getting too hot. I can get spare parts coming in. Reacting to failures can cost a lot. Overnight shipping of replacement parts or a plane ticket for a technician to visit will blow the budget. With our road trip analogy, if the engine seizes because it ran out of oil, you could be paying for a tow, a new engine, and hotel rooms until a rental car becomes available. Regularly changing the oil and checking the level before heading out on a trip avoids future problems. Another reason to have a plan is that outages for maintenance can be scheduled. This helps in 2 ways. First, you can choose a downtime when the equipment is not being heavily used. Second, you don't interfere with the production schedule. The scheduler can plan to work around the outage ahead of time. And finally, proactively monitoring equipment can detect and address imminent failures. We find problems before our customers do. Calibration can be needed for equipment or measuring devices. Proactively calibrating keeps assembly processes in spec and avoids scrap. In addition to the electronics test equipment, we need to calibrate the pick and place machine anytime we replace belts or other parts that wear down with time. When we're placing a part whose connection centers are 0.5 millimeter apart, tolerances are critical. If the part is placed off center, it's likely the entire assembly will need to be scrapped. Another example where calibration is important is with CNC machines. They need positions calibrated, so calipers and depth gauges need to be checked for damage and accuracy at regular intervals. If a batch of parts is run and the calipers used during setup were off, the entire batch might not meet spec and need to be scrapped. Knowing your equipment is calibrated gives you confidence that the product is being built in spec. Another reason is to avoid field failures. In my earlier example, if the laser diode driver ships but doesn't produce adequate current, the customer will return it and will get a black eye. So proactively managing equipment is important to keep production flowing, for good customer relations, and to avoid creating waste. So where do we start? First, setting up an equipment management plan involves risk analysis and risk mitigation. The first thing you need is a list of equipment being used. The scope of the list can be the entire company or just manufacturing. The list should be exhaustive. It's easier to remove something from the list than it is to notice it the first time it fails. The list can cover anything from computers that need software upgrades to company trucks that need oil changes. You set the criteria for what goes on your list. Making the list can be as simple as walking around to see what tools people are using. Looking through my facility, I have machines for solder paste printing, placing parts, reflow ovens, selective solder machines, automated optical inspection equipment, soldering irons, curing ovens, test fixtures, power supplies, servers that hold data. Once you have collected the comprehensive list, the risk analysis starts. For each item, evaluate how likely it is that the equipment will fail and the impact of the failure on your business. That's risk analysis, the process of identifying and analyzing potential issues that could negatively impact a business's ability to fulfill orders. We could devote an entire webinar to that topic, so I won't dive in too deeply. For wavelength, I consider many factors. Will anything on the equipment wear out gradually with use? Examples of this include motors, gears, belts, hydraulics, alignment jigs, capacitors and test equipment, circuit boards, cables that bend frequently, mechanical switches, things like that. Second, are there maintenance protocols in the user guides? If yes, that's a good indicator it needs a preventive maintenance plan. Third, is this line item critical to meeting a published specification? Does it need traceable accuracy? Can its measurements change over time? If yes, it needs a calibration plan. So ask yourself this: how likely is an item to fail? Risk varies with how delicate or complicated an item is. If an item fails, what might happen? Will I create scrap? Will misalignments cause lowered yield, more rework, field failures? Will production shut down? Key to this, do I have redundancy built in, or will production and invoicing completely stop? Is there a lead time on replacement parts? How long would the line be down? Do I have troubleshooting ability in-house, or would I need to bring experts in? So along with this, determine the financial impacts of failure. What revenue will you lose broken down to a day or an hour that the machine is down? Will I need to scrap anything? Will I spend money on repairs? What are the reputation impacts of a failure? What would handling RMAs cost? Get creative with your most cynical team members and brainstorm what could go wrong. Balance that out with the likelihood of those events happening and calculate the costs of a failure. So what can fail and how important is it to business success? For example, on a road trip, what can go wrong? Car part failure, bad weather, fuel supply, you forget something. What are the risks that matter? Once you know what the risks are, the next piece of the preventive maintenance and calibration process is making a plan to mitigate those risks. Consider these typical preventive measures. Keep spare parts on hand. Set up a plan to replace them at intervals. Follow the owner's guide maintenance protocols. Monitor critical processes where a machine failure will affect the quality of what is produced. For example, to populate a circuit board, we stencil on solder paste, load the parts with the pick and place robot, then run the board through the reflow oven to liquefy the solder paste and solder the joints. If any of the 14 oven heating elements is failing, the temperatures will not melt the solder paste and someone will need to rework all the failed joints by hand with a soldering iron. One bad set of boards through the oven could cost several days in hand soldering, reducing throughput and spiking cost of goods. To avoid that, we send a known sample through the oven and monitor the actual temperatures against the expected temperatures every week. We also spend the money to have one spare heating element on hand. We can replace the element in 4 hours, then buy a new spare with ground shipping. For our road trip example, what equipment on the car is critical to operation? Engine, transmission, tires, windshield wipers, turn signals, and so on. What can I do to mitigate the risk of failure? The manufacturer recommended maintenance, oil changes and belts. Monitoring. I'm going to check air pressure on my tires and see what tread level is left before I leave. I'm going to get an oil change and check oil level before I head out on the trip. Am I going to pack spare parts? A spare tire, yes. Spare fuses, yes. Spare windshield wipers and belts? Probably not. I'm definitely not going to tow a spare engine around with me. Mitigating all risk is expensive. Consciously choose what risks are acceptable and which need to be addressed by the equipment management plan. So once you have a plan, it's critical that your team follows it. Consider addressing these points. Make it easy to follow. Make sure you allocate time for the work and money in the budget for replacement parts or consumables. Document the maintenance steps and calendar the tasks. Write up what needs to be done. Take pictures and store the document. The tasks can simply be listed in a spreadsheet or on a shared Google or Outlook calendar. There is asset management software available too. In any case, keep it simple. The more complicated the process, the more likely people will be to introduce shortcuts to bypass onerous steps or skip filling out forms. Assign a responsible party to complete the work. If multiple people share the work, it's easy to let things fall through the cracks. Then train the responsible party. Make sure that your expectations are clearly communicated. How often does the task need to be done? Are they authorized to replenish spare parts? What budget do they have to work with? Is the task clearly documented? Where do they go if they see something wrong or can't complete the task? Finally, someone needs to monitor the effectiveness of the plan. This is where it's important to have one person who can oversee the entire plan and own the performance metrics. What kind of metrics are typical? Overall equipment effectiveness is a commonly used metric. Simply put, overall equipment effectiveness identifies the percentage of manufacturing time that is truly productive. An OEE score of 100% means you are manufacturing only good parts as fast as possible with no downtime. The metrics you use need to make sense for your company. To make sure the plan is being followed, close the feedback loop. Make sure the work gets done when it needs to be done. Create logs that are dated and initialed for each task, and then make time to review the logs regularly. Track the metrics at known intervals. For example, how many hours was a machine down each month? Or what was OEE for the month? Were there maintenance budget overruns? You determine what to track and how often. If the team didn't hit the metrics, conduct a root cause analysis to determine why. And if the process needs to change, take time to consider if your plan is too aggressive or not aggressive enough. A good equipment management plan will have these 6 elements at a minimum. The master equipment list, documented maintenance or calibration tasks, task lists developed to mitigate unacceptable risks, someone to do the work, logs to prove the work was done, and system monitoring to determine if the plan is effective. An aggressive plan will reduce risk but cost more. A plan that isn't aggressive enough will allow problems that could have been prevented. In summary, a good equipment management plan will keep production flowing, save money, and find problems in-house before they become customer issues. It is important to proactively maintain and calibrate your equipment. Set up a plan that evaluates risk to the company and mitigates unacceptable risks. Monitor the tasks in the plan and whether or not the plan achieves its goals. You can start today. By failing to prepare, you are preparing to fail. For more information about this process and example templates, tools, and ideas, please visit our website at montanaphotonics.org. Thank you for your time.